Welcome to Mr. Urton's video about predicting graph characteristics from the vertex form of a quadratic equation. The problem in our practice test is y equals 3 times the quantity x plus 2 squared minus 5. It's the vertex form because I have a binomial squared and I'm adding or subtracting a number. First of all, the question is, does it have a maximum or a minimum value? Does it have a maximum value or does it have a minimum value? Every quadratic equation has to have a maximum or a minimum value, and that maximum or minimum value actually occurs at the vertex, which we can find from our vertex form. To see how that works, I am going to graph the function on a graphing program similar to the graphing calculators or to the Desmos.com graphing calculator app for the Chromebooks that we use. So I'll put in my equation exactly as I see it, 3 parentheses x plus 2 close parentheses. To do an exponent, I use the little caret, so exponent of 2. I do my squared by doing that, and then minus 5. And I can see on my graph, it shows the graph of that function. And up here in the legend, it shows me the function that I typed in. And I see, first of all, that my vertex is at x equals negative 2. My x coordinate is negative 2. And my y coordinate, the number on the y-axis, is negative 5. It's halfway between negative 4 and negative 6, so I know it's negative 5. And that is also what I saw in my equation. I can get that negative 5 from the equation. That's why we call it the vertex form. The question, though, also asks, does it have a maximum or minimum? We can see it has a minimum value. Minimum is the lowest something can be. And this actually gets down to negative 5, and it never goes any lower. If I make x smaller, then y is going to get bigger. If I make x bigger, then y is also going to get bigger. This is the lowest point it's going to get. It's a minimum point. So I can say that I know it's a minimum point from looking at the graph. Also, I could tell it's a minimum point by looking at the equation. I'm going to edit my function just to show what happens. I'm going to change that 3 to a 1. And if you notice, when I do that, it makes the graph wider, but it does not change the vertex. I'm going to change it back to a 3. And it makes the graph narrower. Now I'm going to make that a negative 3. So we'll see what happens when we make it a negative. The only thing I'm going to change in this equation is that I make it a negative. And you see now it has a negative 3. It has flipped everything over. If I multiply by a negative number, that's going to make all my values negative instead of positive. So the negative sign flips it over. If I have a negative sign here, I actually end up with a maximum value. This is the highest point that this equation, or that this graph will ever reach. It never gets above negative 5. So I can use that in answering my question. Does it have a maximum or minimum value? It has a minimum value, and I can say that I know that because I look at the graph on the calculator, or I can say that I know that because I have a positive coefficient next to my binomial. I'm multiplying the binomial by a positive number. As far as what the value is, I know that the value is the value of my y on the vertex, and I can say that my vertex is negative 2, because negative 2 makes this 0, makes my binomial 0, and the y value is negative 5, because I have a negative 5 in the vertex form. So I can say my my lowest value, because it is a minimum, is negative 5.